Welcome to my presentation on the future application of battery electric wheeled and telescopic loaders from the perspective of the company Kramer. So I hope everybody knows the company of Kramer. If not, let me say a few words about us. We manufacture wheel and telescopic handlers for construction context. So the machines, they look like construction works, but they can also be a tractor. So our machines can also be a registered tractor. So just to know, in what ballpark we are. So the machine, of course, we are at 19 to 115 kilowatts per hour. So my presentation is structured in 5 items. First, it's about the influencing factors on future drive systems. Then I will talk about technologies, and do a comparison. Then I will talk about the area of application for battery electric machines. And battery electric isn't the end of the discussion. We also need to talk about conventional machines, and I would like to conclude with a resume. Of course, there are certain effects that were discussed, and I would like to talk about a few of them. Operating costs, they will change throughout the years. There are forecasts that in Germany, the greenhouse gas mitigation quota of 14.3% today will go to 53% in the future. Now, from a manufacturer's perspective, there are certain aspects to consider. Basically, alternative powertrain systems and battery electric ones are also available. However, from our perspective, it's quite unclear which systems will prevail, because funding and regulations have a significant effect on the market penetration. Now, funding regulation is something I mentioned. Let me say a few examples. In Finland, battery electric powertrains are supported to increase the registration of these types of cars by 5% by 25. In Sweden, a support by 20%, of funding of 20% of battery electric and hydrogen and hybrid cars are available. What does it mean? Well, currently you could observe a trend towards battery electric vehicles, but that's not a clear trend. So looking at the funding programs on a EU scale or European scale, you see a clear image. So a clear trend from our perspective is not to be observed. As a machine maker, our clients' perspective is very important for our future production. So here we need to be honest. Now, with today's application of electric wheeled machines, a return of invest is only valid in special purpose vehicles. For example, in areas for where we work with people, with cities, in park areas, in urban areas, for horse stables. This is where these systems are very beneficial today. However, there are also other factors from a customer's perspective. It is namely that the machines of loading technology are always operated in fleets. So there are always machines like harvesters or excavators or other vehicles that have a higher energy consumption. And they have a large influence on the available infrastructures for the future powertrain systems. Now, talking about regulations, the Federal Ministry for the Environment was here, and they talked about the stage 6 that we are talking about at the moment by 2030. It's not clear yet, but the exhaust after treatment will be more expensive. So we also don't know the effects of alternative powertrain systems are still unclear. To give you a concrete example, if you go to the website of the Federal Environmental Agency, you see that mobile machine zero emission zones should be established, and this could have an effect as well. CO2 mitigation and reduction is something we mentioned earlier. So here are also some funding programs in France. Writing offs for machines are offered that have hydrogen or electrical battery propulsion systems, and also in Germany we talk about 500 euros of savings on CO2 emissions. So we see that funding is already underway. The last point, we mentioned this also, is infrastructure. Basically, we must say infrastructure for fluid fuels is completely available, which means at gas stations and also in mobile application for agricultural contexts and construction sites. So that's a clear advantage. When we talk about battery electric vehicles, well, we see that connected power of 40 kilowatt hours on large-scale construction sites and also long-term construction sites will be available. On mid-size and smaller ones, also in agricultural contexts, the connected power input will be smaller. So we will have a closer look later. That's a challenge. So let's compare some technological aspects. So basically, the machines that need charging, they have a central function. It's about loading is about lifting things and lowering things, and of course here we need the respective infrastructure. So when we have a battery electric powertrain station, we have two electric engines built in. So it's a rather more modern architecture of a powertrain, which enables the working hydraulics and the driving itself, the driving movement, to be separated. So we talk about 70%. So separating the driving and the working hydraulics can reduce the losses in work hydraulics significantly, especially when in loading technologies this is quite beneficial because the idling losses can be up to 50%. In this picture we see that the batteries are very large. It's a large aspect of the pictures, and we talked about this earlier. So the energy density of such a system is at 300 watt hours for 300 kilograms by 2030. This will be more in forecast. This will be 500 kilowatt hours per kilogram. This is an enormous factor. I would like to talk about this later. Now, electrical power station and the technology and the components are already at hand and mature. However, the application in vehicles is still a major challenge. Development risks and also the development efforts are increased. Looking at the hydrostatic powertrain, as we can see, it's a continuously rotating engine. It's quite economically viable to have them set at one powertrain. As I mentioned, the efficiency sees some downsides, but in terms of costs, that's the best alternative. Technology is very famous, very popular, very famous. They have a long life cycle. They're easy to apply and to assemble, so the risks are way lower. Looking into the future now, the potential for efficiency increases are well known and must be implemented, and I would like to talk about them later. Just to show you one example, an energy flow comparison between a hydrostatic drive powertrain and a battery electric powertrain. So the efficiency can change based on which driveline you're using. A hydrostatic driveline is with a maximum driving speed, which means that losses in the driveline are clearly visible. With a diesel hydrostatically powered drive, a lot of the losses are transferred into thermal energy. Then, of course, we have losses in the drive. It's the usable energy for driving and working is in this case 10%. If we apply this to the electrical drive line, we have around about 10% of charging losses. The efficiency of the working hydraulics can be improved significantly when the driving and the hydraulic powertrains are divided, when there is this respective oil provision, and also with the valve technology, with the right valve technology, the efficiency can be improved. So in the end, 70% of the saved energy in the vehicle can be used. So I talked about the energy density of diesel in a battery electric system. 11,800 kilowatt hours per kilogram diesel. That's a factor of 23 in comparison to electric battery wheels. If we calculate this in a driveline, we also only have a factor 9 between a battery electric system and a diesel hydrostatic system. So the specific energy consumption of a battery electric vehicle is reduced enormously, and in the future this will continue to develop into this direction, and that's the main task that we have at the moment, to have the specific energy consumption of a machine and reduce it to face the issue of energy saving and to reduce that. We always talk about a limited possibility to save energy or to store energy, be it with hydrogen or battery. So this is just one example to show you this. Alternative powertrains have a huge potential here. Just very shortly, I would like to show this image of the research of a research group. We mentioned these data earlier. So these are, or let me say it in other words. So we talked about efficiency of the vehicle, but a honest image, if you get an honest image if you look at the life cycle. Now, looking at the diagrams, if you have a life cycle emission, you have the production of a vehicle, recycling costs, recycling emissions while in operation, and with alternative drive systems or fuel systems, like hydrogen, you also have the emissions of the infrastructure. If you have a fossil-based energy mix and focus on that, and we see that battery electric vehicles have some advantages in their life cycle emissions, but that's still not the solution. If you have a regenerative energy mix as a basis, we see that the combustion engine and the battery electric powertrain in the life cycle emissions are decreasing. This study comes from the automotive sector, so infrastructure emissions are to be considered higher. We see that here the liquid fuel has a better life cycle emission than the battery electric powertrain. Talking about application in agricultural contexts and construction contexts where we have local infrastructure, this infrastructure share of battery electric vehicles can decrease in some cases because there is a local infrastructure in use. Coming to the core of my presentation today, I talked about wheel loaders and telescopic loaders. Now I would like to introduce this diagram to you. This is the installed power area now. Now basically, the installable power is not the limiting factor. The limiting factor is the size of the energy storage. I think this is something we could communicate quite clearly. Today we also talk about the future. So here's my forecast. Assuming that the costs for a battery system will be at 100 euros per kilowatt hour by 2030, and the energy density will be at 500 watt hours per kilogram. So we see a very positive image in the 1 to 4 tons area. Nothing changes. 4 to 6 tons, well, will be almost completely electrifiable. And in niche applications, machine in the area above 6 tons with 100 kilowatts per hour power. So the battery electric powertrain will be in a construction and agricultural context, and in this context it will have a great future, and the potential is great, especially where we have 100 kilowatt per hours. Machines are being constructed and sold, so I think it would be wrong to have a merely battery electric approach. So how can conventional machines be optimized from our perspective? We heard it. So alternative fuels and the use of them, that can be a broad field, but they can contribute to a CO2 reduction significantly. Another important point: the specific fuel consumption of the machine needs to be reduced. So the overall machine efficiency for hydrostatic machines must be optimized. And here's one approach that we have for that. That's one example. You see a motor matrix for 1,000 operating hours. I can see it, I hope you can see it too. You see a dependency between the speed and the torque and the driving speed. So you see that the diesel engine is very active in this area. So this dependency will have the effect on the engine that the engine is not being used in the optimal scenario. So what is the takeaway message from that? The driving speed and the torque needs to be independent. So we need to reduce the sound, we need to reduce the speed times. We heard this in the presentation. This is a very important factor for the future. And what's the core message now? We need a load-dependent performance management in the vehicle, which means the vehicle must be dependent on the machine usage or utilization. The other driving component, the diesel motor, in order to achieve the best usage of the utilization of the machine. That's the necessary step that we need for hydrostatic powertrains in the future. In order to have a practical solution for our customer and to meet climate goals. So let me summarize my presentation. So we have certain influence factors. Vehicles are operated in fleets. So we have construction machines with the highest energy consumption can have an influence on future powertrain systems and on the availability of energy. Funding, subsidies, and legislation will have a significant impact on the market penetration. For example, clients think that reselling is very important for certain machines, but this reselling potential is based on subsidies and legislation, because if they buy a battery electric machine today and don't know the acceptance of the machine in 5 or 6 years' time when they want to sell it, well, this could maybe have an influence on the purchasing decision. Now for loading technology, well, up to 6 tons of empty weight, we see a high potential, especially by 2030. And I think this is a very short-term prognosis. So the transformation of the powertrains will also take place after 2030 and will be improving. Now, the efficiency of an electric driving powertrain will be important to reduce CO2 emissions. As I said, machines have up to 50% of idle time, and so an electric powertrain, and especially the independence between the driving powertrain and the hydraulic work drive will be important, especially in no-load times. And when I compared the efficiencies, if you have the energy density of diesel and battery systems and compare them, well, there is a huge factor in between. I mentioned the factor 23. But if you consider the efficiency of the machine, this factor reduces to 9. And by further optimization steps of the machine and significantly optimized valve technologies, battery electric powertrains will grow in significance for customer contexts and applications. And this brings me to the end. Thank you very much.